Hi, this is Tag again, and today I want to have a look at some GTX 285s. Now, this video is going to be a bit different because I don't really have a plan of what I'm going to talk about. But anyways, these two cards were the cards I bought to run for Country Cup this year. And I'm just going to show you the mods I did to them, and afterwards I'm going to do a Voltmod tutorial, I think, on the PC again to show you the detailed versions. Let me remove these. No one needs stock coolers anyways. As you can see, those were both Zotac cards, and what surprised me was the PCB difference. Now, let's get both of these in frame. Now, apparently there is 3 ref-ish PCBs if you get the Zotac ones. This is a complete NVIDIA reference, the original NVIDIA reference board. There was also a sort of updated one that had some slight changes in the VRM section. I don't know exactly what, but there is this Zotac one, and apparently Zotac decided, I think the reason was that these larger package FATs here were cheaper than the smaller ones that you have here. So they decided to use 2 of those and spread out the VRM more, because this is not really more powerful. It has the same high side FATs here. It just has these as double up low sides. These are not really that high end FATs. They just doubled up on them. And also they moved the memory VRM all the way over here. Now, I'm not sure if this helps or hurts, but one thing is for certain, this card does worse memory clock than the other one. But that might just be because of the memory modules on here being Samsung versus Hynix on the other one. I don't think I can show you this. There's no way this is going to focus, right? Yeah, this is hopeless. Anyways, the reference one is Hynix, this one is Samsung. Now, let's flip them over. As you can see, it's already a bunch of stuff. Zoom in a bit. Now, which one is the top one is Hynix. So let's start with the Samsung card. This one is the Samsung Zotac own reference-ish design. Now, on this one I actually needed those capacitors. Here is 6 capacitors on the memory. Those actually helped on that one to get to 1400. On the other one I also did it, but I don't think there was a point, because I'm running these cards in SLI and basically I'm limited by the weakest card anyways, because asymmetric clocks just lead to instability and weirdness. Anyways, I also added, those are 470 microfarad, 470 microfarad, 2.5 volt aluminum polymers, 6 of them directly behind the GPU. And my usual monitoring style is just cut off not ATX, Molex connector. One for vCore, one for vMem. And then we have the Voltmod here. Not gonna focus, is it? It is actually. Okay. So we have, this is the Zotac style. It's also the style of the later NVIDIA reference PCBs. So the back more or less looks similar, but this like bunch of components is placed a little bit different, because it's basically directly on the back of the VRM controller. Now, here we have basically a typical Voltmod. Now, there is a capacitor here, and on the right side you put your wire to your trim port and to ground, usual feedback mode. The reason why there is a 47 ohm resistor here is just that my smallest potentiometer is 100 ohms, and basically I wanted to lower the resistance, so I paralleled a 47 ohm. If you do the mod and you have potentiometers that are 50 ohms or even like maybe probably even 20 ohms, you can also use those. Tested, the mod is up to 1.3 volts here. I'm not sure how far it could go without any OCP or anything, so take that with a grain of salt, but I can't really run more than 1.3 because I'm on single stage and not the strongest single stage at that, at least on the top card. The bottom card I have a stronger one, but again, limited by the weakest card. So this is the Hynix card. I don't know why I put capacitors on the memory here. That's Hynix memory, it does 1400 easily, even bone stock. Also, you might notice these are like basically a V6 going outward. These are inverted, but that's just because I basically put one C-clamp on this in the middle and then two C-clamps on this on the sides to mount the evaporators on my single stages. So basically that's just so they don't interfere. Here I squeezed everything towards the middle. Another thing I added on these cards. This is the reference PCB, original GTX 285 reference. I added 4 little 330 microfarad SP caps on here. Now again, usual voltage monitoring, and here we have our little trim pot. Now this is a bit different. Again, I'm going to show this afterwards in paint so you can see it, because I'm not sure how well you can see the whole thing here. Here there is usually a resistor, and 0 ohm resistor, and you have to remove it and then replace it with this potentiometer. Now on this one, it's not your typical feedback mode. It's basically the higher the resistance across those two pins is, the higher your voltage is. So not lowering resistance, higher voltage, but the other way around. So this is 100 ohm again, a potentiometer, and that's definitely sufficient. At 86 ohms you're at about 1.3 volts. Also you need here this resistor that's sort of half-as soldered on here is for overvoltage protection, because otherwise you can't get this card to 1.3 volts. That's a 100 ohm fixed resistor. I would recommend maybe using a smaller one. Smaller means higher OCP threshold on this, so using something like a 56 ohm or 47 ohm or something like that would probably yield you 1.4 or something like that volts OCP. So, oh, one more thing in general about 200 series cards. There is a pad here, bottom left of the GPU. This is a 16-legged IC. Now let me grab one of those. I removed those. Those are the ones. You can't see that. Let me check on what they are called. They are ADT 7473s. They're basically a chip that manages temperature monitoring on these cards. And if you leave them on the card, they are going to freak out somewhere between -30 and -60 degrees if you run them cold. So if you want to run them on anything colder than a chiller, I would say remove this one. It's pretty easy. You just heat up the whole IC with hot air and just flick it off the board. Quickly clean the pad so there's no shorts. Not really much to it. Just blow away from the memory IC, just to be safe. Again, this applies to basically all NVIDIA 200 series cards. I'm not sure about the GTX 295s, the dual GPU, but so far I've seen this IC on 260s, 275s, 280 and 285. So also the GTS 250 might be a completely different story because it's basically a 9800 GTX. Is it a GTX? Yeah, it's a GTX, I think. So that's a G98 based chip. That's not really from this generation. It's just a rebrand. So on there, I'm not sure if it has that chip. If it has that chip and you remove it, it's probably not gonna hurt the card. But I'm not sure if it's required. So keep that in mind. Now I think I am now going to move on to showing you the detailed Voltmods on the computer. See you there.
Okay, so here we are again. This is the original reference card where you have to remove this SMD resistor. Now, unfortunately, I didn't take a picture with it still on there, but it's basically just a SMD resistor like that one that you have to remove. From there on, you just put in a variable resistor. That's 100 ohms between these two pads. Now, the difference you can easily see here is that you are not putting the variable resistor between a pad and ground, but in between two pads. You basically, I think this thing has internal voltage divider for the feedback pin, but I'm not sure how this mod works exactly, unfortunately. Anyways, you want to start out at 0 ohm set for this. Too ugly even for me. Set. Because 0 ohm set is basically out of the box condition, so it will run stock vCore. Now, also on this card, you might need overvoltage protection mod, which is, again, this is a bit more typical. This is variable resistor, 100 ohms. Actually, no, forget about variable. Just put a resistor of either 100 ohms or something like 56 ohms will also do on here between this pin, this round probe point here, and ground. Now I use this as a ground pad, this top of the capacitor, but you can also of course use the screw hole. You basically just need the over voltage protection mod here to get over like 1.24 volts ish. Now I run my cards at 1.24 volts anyways, because at that point my single stages are already running at like minus 44, 43 ish, and I didn't see much gain from pushing more voltage into the GPUs because they would just get warmer and warmer, and basically I lost the stability from temperature there. But on LN2 you definitely want way more volts into these. Also keep in mind, always put a fan, a high RPM fan on the VRM, on the MOSFETs. Anyways, so let's continue to the Zotac card. That's one I'm going to talk about later. Okay, Zotac card. Now, here it's a bit more traditional Voltmod, basically just a voltage variable resistor between this right pad on this capacitor and ground. Now, I would recommend using something like a 50 ohm for that. But as you can see, I did something else here. Basically, the lowest one I could find in my collection of variable resistors was 100 ohms, so I paralleled something on there. This is 100 ohm variable resistor, and then I paralleled on there a 47 ohm regular one. That's 100 ohm on top here. Now, of course, you could also just run the 100 ohm, but you get a little bit more sensitivity with this one. Because basically your maximum is going to be something around 40 ohms, and your minimum is still going to be 0. So less voltage adjustment per turn basically. Also here I didn't need any overvoltage protection or anything to get to my 1.24, 1.26 volts on single stage. So also ground point, I only found really this one easily accessible. That's not on a tiny MLCC, that's on the back of a bigger filter capacitor. Anyways, this is the Zotac one. Now let's quickly switch to this one. Now this is something someone else did. This is a NVIDIA reference card. That's the Refresh NVIDIA reference PCB. It's very similar to the Zotac, but if you look, there is a different spacing on these resistors because this one still has the phases all basically on the bottom of the PCB. Anyways, if you zoom in here, you have the same capacitor here. He put 47 and 20 ohms here. Anyways, let's close this just to show you. That's NVIDIA reference card. Two FETs per phase, unlike the Zotac with the 3, but the same layout. So with this, you can, with these two Voltmods I showed you, you can basically mod all 3 PCBs you could get on reference looking cards. At least that I know of so far. There might be some other weird stuff like Zotac did, in which case there might be something else a little bit more specific. But anyways, I hope this helped you, and enjoy your GTX 285s.